Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Talha AlMasri and I'm from Maple Halka. Today I will be presenting you my thermal chemistry project and experiment using only household materials that would normally be discarded or recycled. I created a self-supporting stove which can contain and heat 200 milliliters of water. A household material is something you can find in a typical GTA household. Recyclable is defined as something which has finished its original purpose and can eventually dispose of by your household. The purpose of this experiment is to find the heat absorbed by water. The materials needed are a stove, a thermometer, and a tea light candle. So the base is made out of two lid cans. In between them, it's covered with sand, and it's covered with also tinfoil outside. And the can holder is just a Pepsi can, and it has holes in it to put oxygen in it and to help it create the fire. And the body, it's made out of two cans, one big and one small. And there's some holes at the bottom for the heat to go into the water and help it. It'll be easier. And between it, there's some foam and there's some glue on top. The lid is made out of two lid cans. This one's smaller than the bottom, and there's sand between it, and it's covered with foam. The source of the heat is a standard size tea light candle, which is burned for 1 minute prior to the experiment to standardize its performance. Only the candle can provide potential energy for the experiment. The water's initial temperature should be measured and technically close to room temperature. My initial water temperature is 22.2 degrees Celsius. The water will be heated for 20 minutes exactly, with the time taken from the moment that the burning candle is positioned until the candle is blown out. You may only touch the heater during the first 30 seconds of the heating, or during the temperature measurement at the end. The final temperature is measured immediately after the candle is extinguished, which is 36.2 degrees Celsius. The tip of the thermometer must not touch the sides of the cans during the measurement. To calculate the heat absorbed by the water with the data collected, I used the equation Q equal to M multiplied by C multiplied by delta T. M is the mass of the water, is 200 milliliters. C is a specific heat capacity of the water, which is a given or known quantity equal to 4.9 joules per gram Celsius. Delta T is the difference between the final and the initial temperature of the water, which is 36.2 minus 22.2, which gave me 14 degrees Celsius. Q is a symbol for the heat. When I multiplied the values, the heat ends up equaling to 11.7 kilojoules. Therefore, the heat absorbed by the water is 11.7 kilojoules. Jazakumullah for watching. Assalamu alaikum.